This is part 2 because the headphones died. So we're still on ISN page 31, and now we're going to start OR. That's after the headphones died. All the real numbers that are less than -4 or greater than -2. They want you to write the inequality. So we have x is going to be less than -4, or x could have been greater than -1. And they want you to graph it. So remember, if it doesn't have an equal sign, you are going to use an open dot at -4. Less than means you shaded to the left. An open dot at x is greater than -1, and when it's greater, you had to shade to the right. All right, so they didn't meet up in the middle like the and ones did. The solving is still the same. You have -3h plus 1 greater than or equal to 7, and you have to do that two-step equation. You're going to subtract 1, and then you're going to divide by -3. Oh, careful. When you divide by -3, that means that you switch the inequality at h had to be less than or equal to -2 when I solved the left-hand side. When I solved the right-hand side by adding 5 to both sides, because it's a two-step inequality, and so I have -2h is going to be less than -12. Dividing by a negative number means that I had to switch this inequality, so h is actually going to be greater than 6. So now you're graphing h is less than or equal to -2, or h is greater than 6. So h at less than or equal to -2, I have a closed dot. I have an advantage because while we were waiting for the things to charge, I put the number line on it. All right, when it's less than, you shade to the left. This one, it's open because it's bigger than 6, and you shade to the right. Okay, you don't have any to practice on, so I'm giving you some. Try these ones. There's the ands, and there's the ors. Pause the videos. Make sure you can write them and graph them. Make sure that you can solve them by setting up two equations. All right, after you've paused the video, I'll show you the answers. And there's the answers. I showed you how to solve it. Here's another one that I just want you to take a look at. When right here, when you solved it and it said 3 is less than or equal to x, I always switch it. That means x has to be greater than or equal to 3. So be careful with that one. Otherwise, they were pretty good. Hopefully you did okay. And then the last thing we're going to talk about is special solutions. This is going to be page 32 in your ISN, the very last page we've glued in. And we get some special solutions, just like we did when we solved inequalities. You still are following all the same steps. So you are going to have to distribute. So you have 4x plus 7 is greater than or equal to 4x plus 8 minus 1. You have to combine like terms. 4x on either side, 4x plus 7 has to be greater than or equal to 4x plus 7. Wait a minute. The left-hand side equals the right-hand side, which means it doesn't matter what I pick for x, the left-hand side will always equal the right-hand side, which makes this inequality true because it had that little equal sign right there. Let's try example 2. When we solve this equation, first, of course, we distribute the -3 times x plus 9. We combine like terms on either side, so we simplify. Has to be less than -3x plus 9. Oh, because I wrote it wrong. Whoops. Okay, I've done this way too many times. We're going to redo that one. Because when we're going to add like terms, we're going to get -3x plus 1 is less than -3x plus 9. Sorry. All right, add those 3 x's to both sides. And you get 1 is less than 9. You know what? 1 is always less than 9. So when you get a statement that is always true, that means x can be any real number. It doesn't matter what you pick for x, it will make the statement true. And that's what you want. All right. The last type of problems, example 3 and 4, this is when we get no solution. So let's start solving these equations. Distribute 9x plus 6 minus 2x is less than or equal to 7x plus 2. Combine like terms. Then you move the terms with the variables to the left-hand side. Now when I minus 7x from both sides, I get 6 is less than or equal to 2. That's never true. If you get a statement that is never true, there is no solution. I'm going to let you try this last one on your own. Distribute, combine like terms. You should see that the statement is false and there will be no solution. Okay, that's it for part 2. And then we'll see you tomorrow with all your work done. Bye.